Hello again, students, and welcome to the homework session. Following the theory session of this nugget, you now have a simple calculation tool to help you in your future planning. And you also have an idea of how a simple estimate can be done to figure out the necessary input for a harvesting and collection operation. And you do have an idea of how big this input is in well-functioning systems. So what the homework is about is now to further strengthen these insights and make them a permanent part of your bioenergy thinking. To achieve that, I will ask you to actually analyze a real system. As you see from this slide, what I gave you in the theory session was an example and some guiding numbers for the energy cost in the first steps of the supply. And I said that the first steps end once the primary biomass is loaded onto a vehicle for road transport, or when it is pumped out from the algae farm, or when it, any other way, leaves its site of origin. But for simplicity, I use the terminology of solid biomass, and I call these initial steps harvesting and collection. I also gave you a simple statistical way to estimate the probability that you will run into a fuel shortage. The basis for that was that the annual amounts of the raw material is a stochastic variable. A long series of such data will successively approach the statistical distribution known as the normal distribution or the Gaussian distribution. The method I gave you is not a forecast or a scenario. It is only an estimate of probability and must be treated as such. But using these two things, I will now ask you to analyze the initial steps in a real supply system. But before that, you shall read in detail all 5 chapters in column 3 in the Busy Plan Handbook. All in all, it's only about 80 pages, but this time it shall really be studied seriously and not only scanned. So take your time and go through that material in detail. You might not be aware of that, but the energy system in Sweden, where I live, is based on energy from solid biomass. Looking away from the losses in nuclear electricity generation is the input to the Swedish energy system, roughly 35% energy from solid biomass. Approximately 30% comes from liquid fossil fuel, and that is mainly for the transport sector. Approximately 15% each is hydroelectricity and nuclear electricity, and then there's 5% from other sources. These numbers are very, very rough, but what you understand from them is that bioenergy is by no means anything new, something yet not proven to work, or anything that has to be developed from scratch. Large-scale bioenergy systems are well established since a very long time. However, outside Scandinavia is bioenergy often seen as something new. But at the same time, do more and more people understand that one necessary component in any future and sustainable energy system is bioenergy. So there are lots and lots of small to medium pilot projects all around the world. You may want to look at the IRENA homepage and search for bioenergy, and you will find several publications on the subject. Or maybe you want to scan the homepage of IEA and do the same thing. The International Renewable Energy Agency, IRENA, just like the Common International Energy Agency, IEA, has a lot of different reports and project catalogs and the like, where you will be able to find information about bioenergy projects worldwide. And what you shall do now is to identify at least one bioenergy project in your own region or your own country. Then you shall analyze the first part of the supply in some detail. Questions to be asked are like, how has the project been planned with respect to the primary biomass? If you analyze the statistics, how often will there statistically be a shortage? If there is a risk of biomass shortage, how has the project then taken that into account? And which measures have been taken to guarantee a sufficient feedstock to the project? And then, for the first steps in the supply, what is the cost? Not how much money, but how much energy for the first steps in the supply. When I say the first steps, I mean what I've called harvesting and collection in this nugget. So the steps before the primary biomass leaves its site of origin. This can be when it is first loaded onto a truck at a roadside location near the felling site, or when the flocculated algae slurry is pumped from the algae farm, or when the used frying oil is loaded into a small tanker truck circulating the restaurants in the cities, or when the sanitized slaughterhouse offals are loaded into a railway car, or anything else. The energy cost shall be set in relation to the energy content of the biomass handled. Once you have done this, you will have gained the insights that this nugget wanted to give you, and then you can proceed to the next nugget.